This video introduces the idea of a valid argument, an argument in which the conclusions follow from the premises. Let's start with this example. If you have an onion, then you can log into the classroom computer in Philips 367. You have an onion. Consequently, you can log into the classroom computer in Philips 367. Let's translate this argument into logical symbols. I'm going to let A be the proposition you have an onion, and B be the proposition that you can log into the classroom computer in Philips 367. Then the first statement can be coded as A implies B, the second statement can be coded as A, and the third statement can be coded as B. In this class, we'll use the word argument to refer to any sequence of propositions. The premises of the argument are all the propositions except for the last one, and the conclusion is the last proposition. So our three propositions at the top form an argument. The first two propositions are the premises, and the last proposition is the conclusion. I'll draw a horizontal line to remind us where the premises stop and the conclusion begins. An argument form is an abstract argument, like this one, in which the propositions have propositional variables in them. We say that an argument form is valid if, no matter what particular propositions are substituted for the propositional variables, the conclusion is true if all the premises are true. Recall that in our example, the argument form was this abstract argument in which the premises were A implies B and A, and the conclusion was B. So is this argument form valid? Certainly seems like it should be to me, but let's try to explain why using the definition of valid and the idea of a tautology. From the definition of valid, we have that this argument form is valid if and only if the conclusion is true if all the premises are true. That is, if and only if A implies B and A are true, then B is true. We can write that in a more logically way as if A implies B and A is a true proposition, then B is true. But that's the same thing as saying that the proposition A implies B and A implies B is a tautology. Since an implies statement is a tautology, means that whenever the first part is true, the second part is true. What happens when the first part is false is irrelevant. We can verify that this proposition is in fact a tautology with a truth table. I'll do that here. Notice that this compound proposition is always true, regardless of the truth values of A and B. So this is a tautology, and our argument form is a valid argument form. In general, an argument form with premises P1 through Pn and conclusion Q is valid exactly when the proposition P1 and P2 and all the way through Pn implies Q is a tautology. So for example, the argument form P implies Q, not Q, with the conclusion not P, is also valid because you can check that the compound proposition P implies Q and not Q implies not P is a tautology. By the way, this argument form is called modus ponens, and this one's called modus tollens, but there are plenty of other argument forms, some with names and some without them, because there are plenty of other propositions of this form that are tautologies. Let's look at another argument. If the number 37 is divisible by 6, then it's divisible by 3. The number 37 is divisible by 6, and our conclusion, therefore, the number 37 is divisible by 3. In this example, the argument is these three propositions, and the argument form is the abstract argument that we get by coding the propositions in terms of variables. So I'm going to let P be the number 37 is divisible by 6, and Q be the proposition the number 37 is divisible by 3. So my first proposition is P implies Q, my second proposition P, and my third proposition, the conclusion, is Q. Hey, this is the same argument form we had before, just with P's and Q's instead of A's and B's. We called it modus ponens. So the argument form is valid. We already showed it before, but there's something weird about this example. The number 37 is not divisible by 3. The conclusion is not true. Whereas in the onion argument, the conclusion was true. So how could we have a valid argument form but still have an incorrect, i.e. false, conclusion? Well, if you look closely, one of our premises is false. The number 37 is not divisible by 6, even though the first premise is true. So a valid argument form can still give you a false conclusion if one or more of the premises is false. A valid argument is only guaranteed to give you a correct conclusion if the premises are all true. In this video, we defined a valid argument form as an argument form in which the conclusion is true whenever the premises are all true, no matter what particular propositions are substituted in for the variables. A valid argument is then an argument that has a valid argument form. That is, it comes from a valid argument form by substituting in the specifics for the variables. We saw that we can get a valid argument form from any list of propositions and conclusion where the proposition P1 and P2 and Pn implies Q is a tautology. Valid argument forms are also called rules of inference, and some common rules of inference are given in this table.